Welcome you all. Today I will dealing with surveying subject, surveying practice 2, semester 3rd, course code is 15CE36P. So today I will take presentation on study of parts of a transit theodolite and its temporary adjustments. Aim of the experiment: study of parts of a transit theodolite and its temporary adjustments. What are the instruments required? Theodolite and its accessories. So now we will go for parts of a transit theodolite. First one, rivet. It is a plate having a central circular threaded hole for fixing the theodolite on tripod stand by a wing nut. It is also called the base plate. Now I will show you the part that is a trivet. So this one will be called as a lowermost plate, that is called trivet, having central circular threaded hole for fixing the theodolite on tripod stand by means of a wing nut. It is also called as the base plate. Next one, foot screw. These are meant for leveling the instrument. There are 3 foot screws arranged in between trivet and tryback. So I will show you the 3 foot screws. One is here, another is here, and one more is here. So mainly used for leveling the instruments. So these foot screws are arranged in between trivet and tryback. So this one will be called as a trivet, then this one plate, upper plate, triangular plate, that is called tryback. So in between trivet and tryback, so foot screws are arranged. Next one, tryback. It is a triangular plate carrying the 3 foot screws at its ends. So triangular plate, this one will be called as a triangular plate carrying 3 foot screws at its ends, that is called as a tryback. Leveling head. Trivet, foot screws and tryback together form will called as a leveling head. This portion from here to here, this portion, that is called leveling head. Next one, spindles or axes. There are 2 spindles, one inner and other outer. The inner one is solid and rigid and outer one is hollow. To outer spindle, lower plate is attached, and to inner spindle, upper plate is attached. So that is, spindles are here, it should be not visible. There are 2 spindles, okay, one inner and other outer. The outer spindle, lower plate is attached, and to inner spindle, upper plate is attached. Lower plate graduated from 0 to 360 degree in clockwise direction, provided with a lower clamping and tangent screw. So I will show you the lower plate. This one will be called as a lower plate. So that is graduated from 0 to 360 degree in clockwise direction, provided with a lower clamping screw and lower tangent screw. This one will be lower clamping screw and this one will be a lower tangent screw. Upper plate contains vernier A and B, provided with upper clamping and upper tangent screw. This one will be called as a upper plate, contains vernier A and vernier B, provided with upper clamping, screw and upper tangent screw. This one will be called as a upper clamping screw. This one will be called as a upper tangent screw. Next one, figure shows sectional view of a transit theodolite. Sectional view of a transit theodolite. So this one will be a lid or cap. So vertical axis, this one is called as a vertical axis. Objective telescope, this one is called as a telescope, and this one is called as a eyepiece. This one will be vertical clamping screw. So you have to clamp it. So you will not rotate this. It is a telescope. So you have to unclamp. So you can turn the telescope. This one will be called as a upper. That is a focusing screw, A frame or T frame. This one will be vertical tangent screw. So this one will be called as a magnifying glass. Vertical circle having a vernier C and D. So this vertical circle is divided into 4 quadrants. That is starting from 0 to 90. So from here 0 to 90, 0 to 90 and 0 to 90 degree. So for this one will be called as a altitude bubble. Before taking a vertical reading, so bubble should be at the center. So this one will be called as a level tube or plate level. Next we will go for next one. Theodolite. During surveying operations, various terms are used. What are that various terms? That is a centering, transiting, face left, index bar, altitude bubble, tripod, plumb bob. Centering. What do you mean by centering? Keeping the instrument exactly above the station mark. So keeping the instrument exactly above the station mark by means of a plumb bob is known as centering. Transiting. Turning the telescope about the horizontal axis in the vertical plane through 180 degrees is called transiting. So now you will be turning the telescope about the horizontal axis in a vertical plane like this through 180 degree, that is called transiting. Face left. If the vertical circle of the theodolite is on the left of the observer at the time of taking a reading, it is known as face left, also called as a telescope normal or bubble up. So here see, vertical circle is left side of the observer and eyepiece is towards the observer. That is called face left, also called as the telescope normal or bubble up. Index or T frame provided on stand in front of the vertical circle. It carries vernier C and D. Index bar, this one will be index bar, that is provided in front of the vertical circle, it carries vernier C and D. Altitude bubble provided on the top of index bar, it is to be leveled while taking the vertical angle readings. Next on tripod, next on plumb bob. Face right. If the vertical circle of the theodolite is on the right side of the observer at the time of taking the reading, it is known as face right. So this position will be face right position. It is also called as telescope inverted or bubble down. Changing face. Operation of bringing the vertical circle from one side of the observer to the other side is known as changing phase. Swinging the telescope. It is the process of turning the telescope in a horizontal plane. That is called swinging the telescope. This one we will call as a swinging the telescope. If the telescope is rotated in a clockwise direction, it is known as right swing. Suppose if the telescope is rotated in anti-clockwise direction, it is known as left swing. Next one we will go for temporary adjustments. At each station point, before taking any observations, it is required to carry out some operations in sequence. The set of operations, those are required to be done on an instrument in order to make it ready for taking observation is known as temporary adjustment. The temporary adjustment of a vernier theodolite consists of following operations. First on setting, centering, next on leveling, focusing. First on centering. Setting operation consists of fixing the theodolite with the tripod stand. That is we will call as a setting. Next on centering. The operation involved in placing the vertical axis of the instrument. This one will be called as a vertical axis of the vertical exactly over the station mark. That is we will call as a centering. First, approximate centering of the instrument is done by moving the tripod legs radially. Finally, exact centering is done by using the shifting head of the instrument. Shifting head of the instrument. So you have to move the shifting head of the instrument like this. That is we will call as a centering. Next one, leveling. Leveling. Here there are 3 feed screws. Here there are 3 feed screws. 1, 2, 3. This one will be called as a plate level. First you have to bring the plate level parallel to any 2 feed screws. And rotate these 2 feed screws, first one and second one, inward or outward direction simultaneously until bubbles comes to the center of the plate level. Next, bring the plate level perpendicular to previous 2 feed screws or parallel to third feed screws and rotate the third feed screw in clockwise or anti-clockwise direction until bubble comes to the center of the plate level. So this process is repeated till the bubble comes to the center. That is you will call as a leveling. Next, focusing. First one, focusing the eyepiece. Here, a piece of paper. Here, this one will be a piece of paper, plain white sheet, is held in front of the object glass and eyepiece is rotated. Eyepiece is moved in or out. Eyepiece is moved in or out by turning it clockwise or anti-clockwise direction till cross wires appears distinct and sharp. So I will be keep the paper, this will be paper white sheet in front of the object glass and eyepiece is moved in or out by turning it clockwise or anti-clockwise direction till cross wires appears distinct and sharp. Next one, focusing the object glass. The telescope is directed towards the object. Now I will be directed the telescope towards an object and focusing screw. This one will be called as a focusing screw is turned clockwise or anti-clockwise direction until the image appears clean and sharp. Until the image appears clean and sharp. Next one, setting the vernier. The vernier A is set to 0. Next, vernier A is set to 0. Lower clamping screw is fixed and upper upper plate is rotated till the index of the vernier shows 0. Next, exact vernier coinciding is done with the help of upper tangent screw. Next one, vernier scale. In theodolite, there are two verniers. First one, for measurement of horizontal angles, the main scale is on the lower plate and the vernier scale is on upper plate. Next, for measurement of vertical angle, the main scale is on the vertical scale, vertical circle, and the vernier is on the T frame. Horizontal scale. The graduations on the horizontal scale measured from 0 to 360 degree in clockwise direction. Each degree is further divided into 3 divisions. The smallest division on the main scale is 20 minutes. The vernier is generally so designed that 60 divisions. Therefore, least count equals to 1 by n into smallest division on the main scale, that is equals to 1 by 60 into 20 minutes, that is equals to 20 seconds. So, the least count of the vernier theodolite is, that is 20 seconds. The vernier reads to an accuracy of 20 seconds. There are two verniers. On horizontal scale. These verniers are called vernier A and vernier B. Here, this one will be called as a horizontal scale. Here, vernier A. So, exactly opposite to vernier A, that is a vernier B is situated. The two verniers have index faced 180 degree apart. Exactly should be opposite, that is a 180 degree. Next one, measurement of vertical angle. A vertical angle is angle between the line of sight and the horizontal plane through the trunnion axis of the instrument. The vertical angle is the angle of elevation when the line of sight is inclined upwards from the horizontal line. and angle of depression when the line of sight is inclined downward from the horizontal line. So I will show the in figure. So this will be called as a OH, that is a horizontal line. So above the horizontal line, that is the inclined line, that is a OP, that is you will call position is called angle of elevation. Suppose line of sight below the horizontal line, that is you will call as a angle of depression. For determination of vertical angle between the points P and R subtended at the Trinian axis, measure alpha 1 and alpha 2. Determine the algebraic difference between angles alpha 1 and alpha 2. Take angle of elevation as positive and the angle of depression as negative. So next calculate vertical angle, that is alpha 1 minus alpha 2, that is equals to alpha 1 plus alpha 2. This is regarding the parts of a transit theodolite and its temporary adjustments. Now we will go for the multiple choice questions. First one, dash is the most precise instrument designed for the measurement of horizontal and vertical angle. A. Survey chain. B. Dumpy level. C. Theodolite. D. Telescope. Answer will be C. Second one, a transit theodolite is one in which the line of sight can be reversed by resolving the telescope through 180 degree in a vertical plane. A. True. B. False. Answer A. Third one, horizontal axis is also called dash. A. Inner axis. B. Outer axis. C. Trinian axis. D. Line of sight. Answer is C. Fourth one, by means of vertical circle clamp and its corresponding dash, the telescope can be set accurately at any desired position in the vertical plane. A. Tripod head. B. Focusing screw. C. Leveling head. D. Tangent screw. Answer D. How many types of theodolites do the theodolites classified? A. 2. B. 3. C. 4. D. 5. Answer A. Thank you.